In the vast reaches of space, extraordinary galactic events are unfolding, billions of kilometers away from Earth, sending ripples throughout the universe. One such event is currently drawing closer, catching the attention of scientists and sparking concern. A red supergiant star located at the outer edges of our galaxy is sending ominous signals across the cosmos, detected by the James Webb Space Telescope. Astrophysicists, including Brian Cox, have offered grave warnings about this celestial phenomenon. The pressing question arises: could we be on the brink of witnessing a catastrophic event, a massive explosion that could permanently alter the night sky? Before diving into the details, don't forget to subscribe to our channel if you haven't already. The burning questions remain. Will this event impact Earth, and will it be visible from our planet? Stay tuned as we explore these compelling inquiries in this video. In the grand scope of the universe, where the cycles of birth, life, and death unfold in awe-inspiring ways, one star has recently captured the attention of both astronomers and the general public. This star, known as Betelgeuse, stands out as a red supergiant in the Orion constellation, exhibiting enormous size and age. Its striking reddish hue and fluctuating brightness have long fascinated observers, but recent events have only heightened interest in this cosmic behemoth. Betelgeuse's current stage in its life cycle places it on the brink of a spectacular event. But what do these changes in its behavior mean? Are we on the verge of witnessing an incredible cosmic display? A massive explosion that could reshape our understanding of stellar life? Betelgeuse is truly a star of unimaginable scale. It is so enormous that if it were placed where our Sun is, its surface would extend past the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars. This size not only emphasizes Betelgeuse's physical grandeur, but also signals its position in the stellar life cycle. As a red supergiant, it is in the late stages of its existence, characterized by expansion and cooling after a long period of nuclear fusion at its core. Despite its relatively youthful age in human terms, estimated at around 8.5 to 8.8 million years, Betelgeuse is considered very old in cosmic terms. Its current state as a red supergiant marks the culmination of millions of years of stellar evolution, transitioning from a hot blue star to the massive red giant we observe today. One defining characteristic of Betelgeuse in its current phase is its distinctive red color. This hue is the result of its cooler surface temperature compared to stars like our Sun. While the Sun shines at around 5,500 Kelvin, Betelgeuse's surface is much cooler, around 3,500 Kelvin, causing it to emit light in shades of red. This color not only serves as an aesthetic trait but also provides insight into the star's physical condition and the ongoing processes within its massive atmosphere. Adding to Betelgeuse's intrigue is its unusual history. Ancient texts from Roman and Chinese sources suggest that, nearly a millennium ago, Betelgeuse appeared yellow, but by the 9th century, Arabic astronomers had noted its red hue. This change in color is not only a fascinating historical note, but also a marker of the star's remarkable evolutionary journey. Another remarkable feature of Betelgeuse is its variability in brightness. It is classified as a semi-regular variable star, meaning its luminosity undergoes periodic changes. This fluctuation has captivated astronomers for centuries, with Betelgeuse typically following a 420-day cycle alongside a longer 5-year cycle. These changes were first recorded by Sir John Herschel in 1836, and possibly even earlier in indigenous oral traditions. However, what truly sets Betelgeuse apart is its unpredictability. Unlike most stars that follow regular patterns, Betelgeuse sometimes deviates from its expected dimming and brightening cycles. This irregularity hints at complex and not yet fully understood processes unfolding inside the star's immense structure. In late 2019, Betelgeuse underwent a dramatic and unexpected dimming event, known as the Great Dimming. At that time, Betelgeuse, once shining brightly in the night sky as part of the Orion constellation, began to fade significantly. This dimming was so pronounced that the star lost brightness at an average rate of 0.01 magnitudes per day, reaching its lowest point by February 2020. Betelgeuse, which had been easily visible to the naked eye, even amidst light pollution, became noticeably dimmer, and even amateur astronomers couldn't help but notice the change. However, tracking the behavior of Betelgeuse presents a unique challenge. The time delay caused by the vast distance between us and the star. Betelgeuse is located about 725 light-years away, meaning that the light we see today actually left the star nearly 725 years ago. This time lag makes it difficult to observe and predict sudden changes in the star's behavior, as we are essentially seeing events that occurred in the distant past. The dimming of Betelgeuse serves as a clear reminder of the time discrepancy that complicates our understanding of stellar events in real time. In conclusion, the current and future developments surrounding Betelgeuse are raising important questions and fueling scientific curiosity. As we continue to monitor this extraordinary star, its behavior may offer new insights into the life cycles of stars, and perhaps even provide a glimpse of a future cataclysmic event that could change the night sky complexities of the universe and the limits of our understanding come to the forefront as we wrestle with the vastness of space and the enigma of time. One such intriguing mystery involves the fascinating journey of the star Betelgeuse. This massive star, also known as Insect JW, is being closely observed by Andrea Dupree, the associate head of the Center for Astronomy at Harvard and Smithsonian. Working with her team and utilizing the Hubble Space Telescope, Dupree's team embarked on a 3-year study to monitor Betelgeuse's outer atmosphere. Their observations provided a unique understanding of how a variable star like Betelgeuse behaves, tracking its periodic expansions and contractions that lead to fluctuations in its brightness. The exceptional sensitivity of the Hubble Space Telescope to ultraviolet light allowed the researchers to examine the layers above Betelgeuse's surface, which were partially heated by the violent convection cells within the star. The study also involved a detailed analysis of the Hubble spectra collected at various intervals throughout 2019 and 2020. This enabled them to measure the material movement in Betelgeuse's outer atmosphere, particularly focusing on the magnesium-2 lines in the spectra, which reveal conditions in the star's atmosphere. Their observations indicated material traveling at speeds of around 200,000 miles per hour from Betelgeuse's surface into its outer layers, where it eventually expanded over vast distances, forming a precursor to the dust cloud responsible for the star's dimming. Dupree and her team concluded that during a 3-month period, Betelgeuse shed approximately twice the usual amount of material from its southern hemisphere. This mass loss is especially noteworthy because, like all stars, Betelgeuse constantly sheds mass, but at a much higher rate than our Sun. The scale of this mass release and the resulting dimming raised questions among astronomers about whether it could signal an impending supernova explosion. Given that Betelgeuse is located roughly 725 light-years away, such an event would be visible from Earth, providing a unique opportunity to closely observe a supernova. However, the question remains: does this dimming indicate Betelgeuse's eventual explosion, or is it simply a temporary phase in the star's complex life cycle? Several theories have been proposed to explain the dimming event. One suggests that it could be a stage in the supernova process, as Betelgeuse nears the end of its life cycle. Another popular theory involves dust originating from the star itself, blocking our view of Betelgeuse. A third hypothesis explores changes in the star's photosphere, which could affect its apparent brightness. Spectroscopic data revealed a decrease in Betelgeuse's effective temperature, suggesting the presence of a large dark spot on its surface. These findings were supported by observations showing a temperature drop of at least 170 Kelvin during the dimming period, indicating significant changes on the star's surface. Ultimately, the key to unraveling this mystery lies in humanity's careful study of space. Hubble's precise observations revealed that Betelgeuse's dimming was likely caused by a significant outpouring of heated material into space, which cooled and condensed to form a dust cloud that obstructed part of the star's surface. This material was ejected from a massive convection cell on Betelgeuse's surface, traveling through its hot atmosphere to cooler outer layers. Once cooled, this plasma formed dust particles, resulting in a cloud that blocked light from around a quarter of the star's surface. The development of this dust cloud was confirmed by spectroscopic observations that began in January 2019, which detected signs of dense, heated material moving through the star's atmosphere in the months leading up to the dimming. By December 2019, ground-based telescopes also observed the dimming, particularly in the star's southern hemisphere. The material initially appeared brighter than the star's usual brightness but eventually dissipated, forming a shadow that cooled and spread outward. The scale of this mass ejection was astonishing, with Betelgeuse releasing about 400 billion times the mass typically expelled in a normal coronal mass ejection, a volume of material large enough to encompass the Moon multiple times. This remarkable event not only brought Betelgeuse into the astronomical spotlight, but also advanced our understanding of stellar mechanics. Yet, the implications of such a massive release of material are still being debated. Traditional wisdom suggests that red supergiants like Betelgeuse shed mass in their final stages, but the magnitude of this release challenges this notion, hinting at a possibly more volatile end for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion in the coming centuries? Recent studies have suggested that such an event may occur sooner than previously expected, potentially within just a few years. Another fascinating aspect of Betelgeuse's behavior is its bow shock, a shock wave created by the star's motion through space at about 67,000 miles per hour relative to the surrounding interstellar medium. This bow shock is similar to the wake left by a boat moving through water, and it highlights the star's dynamic interaction with its cosmic environment. However, the observed changes in Betelgeuse's behavior, its cooling surface and decreased density following the mass ejection, suggest that the star is in an unsettled state, even years after the event. Hydrodynamic simulations indicate a link between the star's convective activity, the mass ejection, and the resulting changes in its oscillations. This ongoing instability raises questions about the internal processes driving these changes and their potential consequences for the star's future. Moreover, the observed rate of mass loss from Betelgeuse exceeds that of many other stars, indicating a complex interplay of internal forces. With energy constantly dissipating through shock heating and mass ejection, Betelgeuse's pulse is shifting. The very nature of these mass losses challenges our understanding of stellar evolution, prompting astronomers to rethink their models of stellar life cycles.